Good day, I am Ayan Sidungog, a BS Mathematics student of Negros Oriental State University, and we'll be discussing about probability distributions for today. But first, let me show you our learning objectives. Learning objectives. Number 1. How to distinguish between discrete random variables and continuous random variables. Number 2. How to construct a discrete probability distribution and its graph, and how to determine if a distribution is a probability distribution. Number 3. How to find the mean, variance, and standard deviation of a discrete probability distribution. Number 4. How to find the expected value of a discrete probability distribution. Random variable. A random variable x is the number value related with the outcome of the probability distribution, which has two types: the discrete random variable, which has countable number of possible outcomes, and the continuous random variable, which has uncountable number of possible outcomes or can be obtained by measuring. Now, let me show you an example and determine whether each random variable x is discrete or continuous. Number 1. Let x represent the number of Fortune 500 companies that lost money in the previous year. Since the number of companies that lost money in the previous year can be counted, remember that a discrete random variable has a countable number of possible outcomes. Therefore, this problem shows a discrete random variable. Let x represent the volume of gasoline in a 21-gallon tank. Since the amount of gasoline in the tank can be any volume between 0 gallons and 21 gallons, and remember that a continuous random variable contains uncountable number of possible outcomes or can be obtained only by measuring, and volume is a unit of measure. Therefore, this problem is a continuous random variable. Discrete probability distribution. In discrete probability distribution, you need to list each possible value the random variable can assume together with its probability, and can only be applied if the two conditions are met, such that: Number 1. The probability of each value of the discrete random variable is between 0 and 1 inclusive. Number 2. The sum of all the probabilities is 1. How to construct a discrete probability distribution. Now, we let x be a discrete random variable with possible outcomes. So number 1, make a frequency distribution for the possible outcomes. Number 2, find the sum of the frequencies. Number 3, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. Number 4, check that each probability is between 0 and 1 inclusive, and that the sum of all the probabilities is 1. Example: an industrial psychologist administered a personality inventory test for a passive-aggressive traits for 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. First thing we need to do is to divide the frequency of each score by the total number of individuals in the study to find the probability for each value of the random variable, such that P of score 1 is equals to 24 over 150, which is equals to 0.16. Probability of number score 2 is equals to 33 over 150, equals to 0.22. Probability of score 3 is equals to 42 over 150, which is equals to 0.28. Probability of score 4 is equals to 30 over 150, which is equals to 0.20. Probability of score 5 is equals to 21 over 150, which is equals to 0.14. So, the discrete probability distribution are shown below. Now, we can confirm that this is a valid discrete probability distribution since each probability is between 0 and 1 inclusive, and the sum of the probabilities equals 1. Now, let me show you the graph of the discrete probability distribution that we had. Because the width of each bar is 1, the area of each bar is equals to the probability of a particular outcome. Also, the probability of an event corresponds to the sum of the areas of the outcomes included in the event. You can see that the distribution is approximately symmetric. Now, let me tell you, in verifying or determining a probability distribution, remember that one must always satisfy the following conditions such that the probability of each value of the discrete random variable is between 0 and 1 inclusive, and the sum of all the probabilities is 1. Again, remember that the probability of each value of the discrete random variable is between 0 and 1 inclusive, and the sum of all the probabilities is 1. Mean. In finding the mean of a discrete probability distribution, multiply the value of x to its corresponding probability and the products are added, such that mean is equals to the summation of x times the probability of x. Let me give you an example in finding the mean. The probability distribution for the personality inventory test for passive-aggressive traits is given. Find the mean score. So now we use the formula for mean, which is equals to the summation of x times the probability of x, such that we will first solve x times p of x. After finding x times px, add all the products of it, and so we obtain that the mean is equals to the summation of x times p of x is equals to 2.94, which is approximately 2.9. Now, for finding the variance and standard deviation of a discrete probability distribution, the formula is given below. Remember that in finding the mean, the variance, and the standard deviation, you need a given x and the probability of x. Say, for instance, these examples will give you the idea on how mean, the variance, and the standard deviation are connected to each other. Expected value. The expected value of a discrete random variable is equals to the mean of the random variable, such that e of x is equals to the mean, which is equals to the summation of x times the probability of x. Example, at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500 to $50, $150, and $75. You buy one ticket, find the expected value, and interpret its meaning. So, to find the gain for each prize, subtract the price of the ticket from the price given below. If you do not win a prize, your gain is $0 minus $2, which is equals to negative $2. So, as shown in the presentation, you can expect to lose an average of $1.35 for each ticket you buy. That's all for today. I do hope that you learn and enjoy the video. Thank you.